This will be for the con exercise, unit circle with radians. For each point on the circle, select the angle that corresponds to it. Click each dot on the image to select an answer. So on the unit circle, when you draw an angle, one side or ray of the angle is going to start at the positive x-axis, and then you travel in the counterclockwise direction. Okay, so if we travel from here to here, that's 90 degrees, but in radians, that's going to be pi over 2. And if you travel further, that's another 90 degrees, which is 180 degrees, but in terms of radians, that's just pi. And if you travel another 90 degrees, that's going to be 3 pi over 2. And finally, another 90 degrees, that's going to be 2 pi. Okay, so this here at the 90 degree mark is the equivalent of 1/2 pi. And of course, pi is the same as just 1 pi. So our first point, this is one side of the angle, and the other side, you start at the origin and you just draw a radius to the point. So we're looking for this angle right here. Okay, so even though once around is 2 pi, but when you start here, you're starting at 0. So this angle is going to be between 0 and 1/2 pi. Let's look at the answers. Okay, so it's going to be less than 1/2 pi, but greater than 0. Pi over 4, that's the same as 1/4 pi. So I think that's going to be the answer. Okay, 5 over 6 times pi is greater than 1/2. 4 over 7 is greater than 1/2. 7 over 4 is greater than 1/2. So it has to be the 1/4 pi. All right, so I'm going to click on the, let me see if it took it here. Yes, there's a check mark there. So for that one, it's 1/4 pi. Okay, now we're going to do the next point. Okay, so we're traveling, and we're going to draw from the origin, and we're going to draw a radius to that point. So we're traveling all the way from here to here. Okay, so we went past 1/2 pi, but we didn't go all the way to 1 pi. So it's going to be in between 1 pi and 1/2 pi. Okay, so let's see. It's either going to be 5 over 6 pi or 4 over 7 pi. Let's see. Okay, for this one, I'm going to have to convert. All right, we know that pi radians equals 180 degrees. So for the 5 pi over 6, we're going to look at 5 times 180 divided by 6. Okay, 180 over 6 is 30, and 5 times 30 is 150. And for the 4/7 pi, that's going to be 4 times 180 over 7. And I'm going to need the calculator for that one because I can't cancel anything. 4 times 180 divided by 7 is approximately 103 degrees. Okay, so looking at this angle between 150 and 103, I think it's going to be 150. Okay, which makes it the 5 pi over 6. So I am going to check that one. Okay, if you'll notice, for the 150, that would make this angle here, 180 minus 150, about 30 degrees. So yeah, I would estimate it that it's the 150, okay, which was 5 pi over 6. So once in a while, you're going to have to convert them. Okay, finally, for the last one, if we draw the radius from the origin to the point, we're going all the way around here. Okay, so we went past 3/2 pi, but we didn't make it all the way to 2 pi. Okay, so it's going to have to be greater than 3/2 pi, and it's definitely greater than 1 pi, so it can't be, all of these are less than 1. See, all the fractions times pi are less than 1, so it has to be the 7 pi. 7 pi over 4, 7/4 pi. Okay, again, we have our unit circle, and they want to know what is the value of the y-coordinate of point A. And all their answers are in the form of sine and cosine. All right, so first we have to find the angle theta. Okay, remember we start here at the positive x-axis, and you travel counterclockwise. Okay, so we want to find that angle theta. All right, we said if we go from here to here to this side, that's going to be 180 or pi radians. And then if we go from here to here, this point is 3 pi over 2. All right, so if we made it just here, that would have been 3 pi over 2. We just have to add in this angle right here, which is pi over 4. All right, so it's going to be, if we went all the way to here, 3 pi over 2, plus this is pi over 4. Okay, 3 pi over 2, plus pi over 4. Okay, you need a common denominator. So we want 4 in the denominator. Multiply top and bottom by 2. So 3 over 2, 3 times 2 is 6. 2 times 2 is 4, and we still have pi. And this is plus pi over 4, which is just 1/4 pi. So that makes it 7/4 pi, 7 over 4 pi. Now, recall from a previous exercise, the x-coordinate is the cosine of the angle. So the x-coordinate is the cosine of 7/4 pi, and the y-coordinate is the sine of 7/4 pi. All right, so they are asking us the y-coordinate of point A. So that's going to be sine of 7/4 pi. Or 7 pi over 4. All right, so don't just choose pi over 4, because you have to start at the positive x-axis and go counterclockwise. All right, so here they want the x-coordinate of point A, and this one here is right on the positive x-axis. So that doesn't even go anywhere. That's just 0 degrees, which is the same as 0 radians. Okay, so the coordinates for that point, the x-coordinate is the cosine of 0, and the y-coordinate is the sine of 0. Okay, I guess I shouldn't put degrees because these are in radians. So it's cosine of 0 and sine of 0. They're asking for the x-coordinate, so it's going to be the cosine of 0. Okay, last one. Which of the coordinates is equal to the sine of 11 pi over 6? So we have x and y coordinates, A, B, and C. All right, we're looking at 11 pi over 6. You certainly can convert this to degrees if you want to. But if we had 12 pi over 6, that would be the same as 2 pi. And 2 pi is going all the way around the circle. So since we have a 11 pi over 6, it's going to be a little bit less than 12 pi over 6, or a little bit less than 2 pi. So clearly, 11 pi over 6 would be the one that's almost reaches 2 pi, but not quite. So if we don't quite go all the way around, that's going to be that point right there. Remember, you draw the radius from the origin to the point. All right, and the x-coordinate is the cosine, and the y-coordinate is the sine. Okay, and they're giving us the sine of 11 pi over 6. So it's going to be the y coordinate of point C.